Number 78. Which compound or element has the lowest boiling point? So you're given, this is an element, this is Cl2, and then you have a compound and a compound. Now, the key here is that ionic compounds are very hard to boil because they're made of positive and negative ions. So if you got, this is discussed in the lecture, if you got an, here I'll just kind of draw you a bunch of ions. Okay, remember, so solid ionic compound, it's held together very strong, all of the positive and negative ions, so it's very hard for these guys to just vaporize and all of the charges separate. Okay, so the boiling points are very high for ionic compounds. Ionic has high melting points and boiling points. Okay, and then covalent compounds and elements those are not made of ions. Those are made of atoms and molecules. Okay, covalent compounds are made of molecules, and elements are sometimes made of atoms, sometimes made of molecules. In this case, this element is a molecule because you got two. And these are much easier to boil, so they have lower melting points and boiling points. So when you see these three over here, you should be identifying this as an element, and that's an element. But these two over here, those are both ionic compounds. That one and that one. And you can identify them as ionic compounds because you got a metal and a nonmetal, potassium and iodine, lithium and fluorine. So these guys will have higher boiling points, and that chlorine will have the lowest boiling point. Cl2 has the lowest boiling point. Now suppose this problem asked you to put the boiling points in order. This one would be the lowest. Which one would come next? Cl2 would be the lowest, and then suppose you're putting them in order of increasing boiling points. Well, it turns out that Ki has a lower boiling point than Lif. They would both be much higher than Cl2. Ki and then Lif. The reason this one has a lower boiling point than that one is because the K plus ions, these guys, okay, they are much larger than the lithium ions. Okay, and so if you have a very large ion, compared to a small ion, and then of course you got the iodide and the fluorine. The iodide is a very large ion, and fluorine is a very small ion. Large ions are kind of forced to be, you can't see that, there you go. Large ions are forced to be far away from each other. Smaller ones get closer together, and these smaller ones hang on to each other, okay, much better than those. Think about two planets that are very far apart. The force of gravity isn't as good, isn't as strong, but planets are closer together, the force of gravity is stronger. And anyway, the closer two ions are to each other, the stronger they are, so the harder it is to boil. I wouldn't expect you to know this part, how to differentiate this one and this one, but you should know that these guys are both greater in boiling points than that one over there, because these are ionic. These are ionic, and that is not ionic.